Hey, what's up guys? Back again with another video in the Java I/O series. This episode I'll be teaching you about Java filter streams. So Java filter streams are a subset of the different streams you could use for input streams and output streams. It's a subclass of input stream and output stream, and I'll show you how that looks in a second. But it's a really cool type of stream that allows you to establish a filter on another stream. So basically you have two streams. You have the filter stream, and then under that filter stream, or connected to that filter stream, you have what's called a underlying stream, which is a regular output or input stream, okay? And that filter stream is going to basically filter any data that comes into the stream if it's an input stream, and then any output data if it's an output stream. So it allows you to manipulate the data before it's written to a stream or inputted from a stream, okay? So you're going to see how it works even more in a second, but that's the simple explanation. It's very similar to a water filter because it allows you to filter data within a stream, okay? It's really cool. So if we look up our class hierarchies here, let's go over here. If we look up the Java docs for the the Java class input stream, we know this class by now. It's just the top of class for our streams in Java. And this class itself, of course, establishes all these different methods here for an input stream. And then under that, as subclasses, we have these different concrete classes like audio input stream, byte array input stream, and then file input stream, which we've gone over, and then we have filter input stream, and then we have other ones here. So as you can see, we already went over file input stream, but right beside that is a filter input stream. But as you can see, they're both related in the sense that they have a superclass of input stream, okay? So they're just another type of stream. So if we click on this here, we can view the class itself. So if we take a look here, we can see that it has a bunch of stuff. We have constructors here, which we'll go over in a second, and then we have all the different methods here, which is basically all the methods that were inherited from a regular input stream class. So yeah, we're going to go over that, but at least you know how it all relates together, okay? You just need to understand that a filter input stream is still a regular input stream, except that it's going to allow you to do some special things because its methods are customized in a way, okay? So that's pretty simple, but if we go to output stream, now we could do the same thing. We could see that we have the different subclasses of output stream here. We have byte array output stream, file output stream, which we've gone over, filter output stream, object output stream, and then piped output stream, okay? So of course we've gone over file output stream, as you know, but then we can click on filter output stream, and here we have pretty much the same exact thing except for outputting. And yeah, so this is going to be the stream that allows you to establish a filter with any other stream, okay? So yeah, very simple. So you just need to understand the relationships between all the different classes, because it may get a little confusing, but just in the end know that it's still an output stream, it's still an input stream when it comes down to it, right? So anyway, let's continue our presentation here. Alright, so how do they work? How does a filter output stream and a filter input stream work? So a filter output stream can be boiled down to this. It's just this simple explanation here. Filter output streams alter the data before it goes down to the underlying stream. Alright? And then filter input streams alter data from the underlying stream before it reaches the program, okay? So if you don't know exactly what that means by reading it, I made this little diagram for you right here. And so this is a good representation of how this works, okay? So this is a filter input stream here at the top, meaning it's going to manipulate data before it gets into the program. So right here you have your hard disk, right? So we can establish maybe a file input stream with this. So the file input stream by default is just going to connect from the hard disk to the program, like we did last episode. But what if we add a filter stream on top of that, file input stream? That means that it's going to filter the data before it comes to the program. So before the program even is able to read the data, it's going to be filtered, meaning it's going to be altered in some way. Then the altered data will come to the program, okay? So it's basically like a middleman type of stream. So it connects to a regular stream, and then it alters the data before it gets to the program. Very simple. And then a filter output stream is basically the exact opposite. So whenever the data leaves the program, it's going to have a filter in the middle, basically, that's going to alter the data before it reaches the output stream itself, the underlying output stream as it's called. So yeah, it's just going to alter the data before it reaches the underlying stream, which is again the stream that the filter stream is connected to, okay? So yeah, that's pretty simple. There we go. So how do we create a filter stream? And so yeah, we have the two constructors here. We have filter input stream and we have filter output stream, and they both have one parameter. That's the only parameter that you can accept to instantiate any of these or subclasses. And for example, for filter input stream, we just have a single input stream class here as the parameter, or object, I guess you could call it. So this means that we can accept any subclass of input stream itself, right? Because we don't actually declare an object of input stream, we just declare objects of its subclasses. So a good example would be FilterInputStream. So we can establish a FilterInputStream inside of here that is connected to a FilterInputStream. So you're basically filtering file input data like we explained right here. This would be a FilterInputStream, and then it's connected to a FilterInputStream. Okay, and the same thing for FilterOutputStream, right? All you're going to do is provide a outputStream subclass, any subclass of outputStream. Like for example, if we go back to our little Java docs here, let's say we want to make a new FilterInputStream, right? All we got to do is figure out which output stream we want to provide, right? We could do audio input stream, byte array input stream, file input stream, all these different input streams we could provide as a parameter to create a filter input stream. Because the filter is not really a stream itself, it's more of like a thing that alters the data in the stream, and then the underlying stream is really the most important thing because it's where all the data comes from and comes to, for output streams. And again, these are called the underlying streams, the one that it's connected to. And we're going to get plenty of practice with this, but by the way, you're not going to actually declare an object of FilterInputStream. You're going to declare an object of one of FilterInputStream's subclasses. So if we go to FilterInputStream, we can see that it has its own subclasses here, like BufferedInputStream, CheckedInputStream, CipherInputStream, DataInputStream. We have all these different filter input streams that we can use to filter data in some way. So just know that you're not going to actually declare an object of FilterInputStream for the most part. Same way you would do with InputStream itself, right? It's concrete actually, but you're still not going to want to declare an object of it because of its parameters and you just don't want to, okay? So anyway, let's look at the methods now. So right here we have methods for a FilterInputStream and then a FilterOutputStream. And as you might have noticed, they're the exact same methods that you would find within a regular input stream or regular output stream. And this is important because whenever you call maybe the read method, for example, or the write method within a FilterInputStream, it's also going to call the write method within the underlying stream. So for example, over here we have a method that you might be able to find within a FilterInputStream subclass. You have a public void write, so it's a write method, it's overriding the write method found within this class here. And then inside of it, you can see that it's calling upon super.write, which is a reference to the underlying stream. So even though you're calling the write method of the filter stream, it's still, in the end, you're going to be calling the write method within the output stream, or with the underlying stream in this case. Because in the end, it's still outputting data, it's just going to manipulate the data, as you can see here, before it reaches the point where it wants to write the data, okay? So again, just to reinforce that idea, it's just going to manipulate the data, then it's going to write to the original output stream in the first place, the underlying stream. So that's why all the methods are the exact same, is because it's still calling all of these methods within the underlying stream, except that it's going to manipulate the data before it reaches the underlying stream itself, okay? Alright guys, so now that we know the basics about how a filter stream works, let's make a custom filter output stream so that you can see in detail what is occurring behind the scenes. So the reason we're going straight to making a filter stream rather than using and testing one out is because they're all unique in how they work. We have BufferedStreams, which is a type of filter stream, and we have other ones, right? So they're actually very unique in how they work, meaning that we need to make a separate video for each of those because they're pretty detailed. So yeah, that's what I'm going to do. I'm going to make a separate video for each of those in the future so that we can look at those close up. And next episode, for example, we're going to be going over the BufferedStreams, okay? So anyway, just be aware of that. So the reason, again, behind making this custom one is so that we can see behind the scenes how it's filtered, where the data goes, how, any stuff like that. So let's get started here. What I want to do first is we need to make an underlying stream, as you know, because a filter stream has, the filter stream itself, but then that filter stream is attached to a underlying stream where the data is actually coming from or going to. So in this case, we're just going to tout output stream. So we're going to make, let's make a new file output stream. So file output stream. All right. And we're going to call this fout, I guess, is equal to new file output stream. And then inside of here, we can provide a file. So we can provide a name or anything like that. We've already done this before, last episode, but let's just call this, output.txt because that's where all the output is going to go, obviously. Cool. So now that we have that, let's do this. Let's make this null. And then inside of here, we'll have the try. And then we can set fout equal to new file output. There we go. So now we can do that. Now we just need to handle the exceptions. IO exception, sout ex. Okay, there we go, and we can close that after, but we'll get to that later. Anyway, so now we have a new file output stream, and what we wanted to do is basically take input from the console. When we type in the console, we want to take that input and then output it into that file. Okay, pretty simple. We've done this before, I think. So first, let's think about how we want to do this. We just need to grab input. So let's do for int I is equal to system dot n dot read, and then we'll do as long as I is not equal to -1. Actually, we'll do as long as I is not equal to x. So when the person who's typing the input into the console, when they press x, that means that it's going to cancel the for loop here. So as long as they don't type capital X, then we can continue by doing I is equal to system dot in dot read. All right, so it should loop through that pretty simply enough. And what we want to do with that input is put it into this output right here for the file. Okay, so we just do fout dot write and then I. All right, so that should do it for us. So let's try running this and see what happens. So it's running at the bottom, it's compiling everything and stuff. And it should ask us for some input because that's what we're telling it to do, to read the input from system.in. So hopefully this will hurry it up. Alright, cool. So now we can type in here, as you can see. So it's asking for input like we told it to. So let's say Cody is really cool. Enter. And then let's press X. And it didn't. Okay, now it stopped. There we go. And so we get our file here. And the file was actually made by default. Like it made it automatically, which is interesting because I didn't have the file there. So that's pretty cool. I didn't know it could do that actually. But yeah, it made the file for us because it didn't exist. And then it put all the input that we just entered into here, except for the X. The X does not count. So that's pretty cool, pretty simple. And now what we want to do is apply a filter to that, right? A custom filter in this case. So let's make a new class to represent that filter. So we're going to call this filter, let's call it custom filter. Custom filter, or custom output filter, because it's an output filter, not an input filter or anything like that. So yeah, there we go. Press enter. And so now if we want to make this inherit everything from a filter output stream, we want to do extends filter output stream. Filter output stream, just like that. And so now inside of here, first we need to have a constructor for our class. So public void so public custom output filter, and then inside of here we need to provide the the underlying stream as a parameter. So we could just do output, and we'll call this output stream. And then inside of here, all we got to do is do super, and then provide out as a parameter. So what that's going to do behind the scenes is basically set the constructor for the super class for FilterOutputStream, and then set the this class here for that. Okay, so what you're going to see in a second is basically what super is going to allow us to do. Now that we've done that in the constructor, we can basically do super.write, and that's going to allow us to access the write method and any other method for the super class, aka the underlying class for our underlying stream. Okay, so hopefully that makes sense, but you'll see that in a second. So first what we want to do is override or start overriding the methods that we can find within here. Okay, so of course if we do public, it shows us all the different methods, and these are of course all the methods that you can find within a filter stream or an input stream or an output stream, excuse me, a filter output stream or output stream, because it's the same thing, right? It's overriding all the methods basically. So let's choose one of these. Let's choose this one, and it's asking for a single byte of output, right? And it's going to hopefully write that output, right? So we just deleted the code that was in here automatically. But what we want to do is eventually write it out by doing super.write, and now we can write the output. Okay, so basically what this is going to do is whenever you call the write method upon the custom output filter stream, it's going to also call the write method within the underlying stream. But before that happens, we want to go here and actually manipulate the data, filter the data before it gets to that point, right? So let's try doing okay, well, let's get rid of this first, because we're gonna do something a little bit different. So let's think about what we want to do for this filter. Okay, let's do something pretty simple. Let's make it so that anything that is entered into the console, whether it be letters, numbers, and stuff like that, anything that is entered, it's all converted to question marks unless it's a number. So it's going to filter everything out unless it's a number. Okay, so it's like a number output filter. Okay, kind of interesting, but let's try that out. So the way we would do that is just do if b, and now we need to pull up an ASCII table so we can see which numbers are representing a number in the ASCII range, okay, or table. Alright, so I got an ASCII table here, and as you can see, we have all the different, letters and stuff like that. Okay, so if we want to target numbers, all we have to do is filter every number, ASCII number 48 through 57. Okay, so let's try that out, because that's going to be what represents numbers. Oops, wrong thing. So let's go here. And so now what we want to do is say if b is greater than or equal to 48, which represents a 0 in ASCII, and b is less than or equal to 57, which represents 9 in ASCII. So if it's within that range, then what we want to do is just output it like normals by doing super.write b. that's going to output B into the underlying stream, okay? But if it's not within that range, what we want to do is else if just, or else rather, then what we want to do is just output a question mark instead. So we're filtering out anything that's not a number, basically. That's our goal at least. So we could just put a question mark character inside of here, and it's going to be automatically converted to the byte form of it. Or we can go into our ASCII table and find the question mark, which is 63. So just, for practice, we'll change this to 63. And that should work. What it should do again is just convert everything that's not a number into a question mark, and then any of the numbers will just be converted, or actually it's not going to be converted, it's just going to be sent to the underlying stream just like normal, okay? So hopefully that makes sense, but yeah, that's how we're doing it. And again, whenever you do super.write, that's a reference to the underlying stream, but if you were to do something like this.write, that's going to be referenced to the top level stream, the filter stream, okay? So let's actually override one more method inside of here. We're going to override the other overloaded version of the write method that accepts a byte array. So let's do this one right here where it has a offset and a length. So we can do that one now. Okay, so now what we want to do is basically just loop through each of the bytes within this byte array here, and then write it out using this write method, not the underlying stream. So we're basically going to call this method for each of the bytes in the byte array, okay? So that's just what's happening behind the scenes normally. So we're going to do that. So we'll do for int I is equal to offset, and then I is less than offset plus length, and then I plus plus. And that's just going to allow us to cycle through or iterate through each of the bytes in the byte array. And then now we could do this dot write, meaning the filter stream, and then we're going to do B and then I for the index. So that's going to plug the byte from here, from the byte array into here, and it's just going to write each one from the byte array into this right here, okay? So it should filter it the same way just because it's going to loop this over and over and over. So hopefully this whole concept makes sense, how to filter it. All we're doing is intercepting the data basically before it reaches the underlying stream. And this is going to be where we print stuff to the underlying stream, but before it reaches there, we're going to filter it with if statements and just stuff like that, okay? So yeah, hopefully that's not too confusing, but now let's go into our main.java and try utilizing this within our file output stream. So what we're going to do here is instead, we're going to do custom output filter. We're going to call this output, and then that's going to be new, and that's going to be null, okay? And then down here, what we want to do is do output is equal to new custom output filter, and as a parameter, what it's asking for is the underlying stream, and this is our underlying stream right here. So all we got to do is just plug in f_out just like that, or we can actually just copy this or cut it and just plug it in just like that. We could do that if you want to, but since we already made that object, let's just might as well use it. And anyway, so now that we have a filter stream here connected to this underlying stream, let's, instead of writing directly to the underlying stream, write directly to the filter stream, which is going to filter it now, okay? So anyway, that should make sense, hopefully, but let's run this and see how it works, okay? So I should build this real quick, and now we can enter input into here, right? It's asking for input, and let's say something like 1, 2, 3, Cody is cool, space 1, 2, 3, 4, 5. Cody is really awesome, right? Enter. Oh yeah, enter doesn't do anything. We need to press X, and there we go. So now let's go into our file here, output.txt, and see if it worked. So there we go. Now we get something a little strange looking. It says 1, 2, 3, question, 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 1, 2, 3, 4, 5, 6, question, question, question. You get the point, right? So what it's doing basically is taking all of this input here and then changing all of the non-number characters into question marks, basically, right? That's how the filter is working. That's exactly how we designed it to work. And now hopefully you see how a filter works. That's all it's doing really. It's just intercepting the data, and then after it works with the data, it's going to change the data in some way by, after it's done filtering it, and then write it to the underlying stream. That's all it's doing. Nothing more complicated than that. So one more concept I want to explain to you is how to close a filter output stream and what's happening behind the scenes when we close it. So let's just add our finally here, and inside of here we're going to do try. And inside of here, we're going to catch it, IO exception, EX, oops, that's out, EX. So now we can just close it like normal. All we got to do is do output.close, okay? So what is happening whenever you do that? Basically what's happening is whenever you do the close method upon a filter stream, it's going to close both the filter stream and the underlying stream, meaning that if you were to open up another filter stream with that underlying stream, it's going to return an error. It's just not going to work because again, it's going to close the underlying stream, so you have to make a new underlying stream if you want to even use it, okay? So for example, if we had a filter input stream connected to a system.in input stream, if we were to do .close upon the filter stream, it would close both the filter stream and the system.in stream, meaning that we can no longer get input from the console because we closed that stream. So we would have to reopen it somehow, okay? So hopefully that makes sense. Just you need to understand that. In the future, you're going to get plenty of practice with that. You're going to get plenty of practice with all of this, especially next episode when we work with BufferedStreams. So yeah, that's pretty much it. If you have any questions about what I showed you today, you can ask in the comment section below. I'll be glad to help you. If you thought I did a bad job explaining, just let me know how I can improve. And all the code for today's episode is going to be in the description below, so check it out. And just bookmark the link for future use in case you forget how to do any of this. It's very useful. And if you want to support this channel, you can click the join button below this video, and you can join this channel as a member for $1, $5, or $10 a month, and you can cancel at any time if you want to. And that's it. So if you like this video, leave a like. If you want to see more, subscribe, and peace.